talked about chemical bonding. We have spoke about ionic bonding. We have started to talk about nonpolar, covalent bonding. And about polar covalent bonding. Now, I know we still have metallic bonding to talk about, but I really don't want to jump into that just quite yet. I want to really focus in on these types of bonds because these are the ones that we mainly focus in on. And you're mostly going to be focusing in on in college. You're going to be focusing in these types of bonds of ionic and covalence. Within this, there's something special. And this gives me a good opportunity to see if you guys got the breakdown of your periodic table right. There's such thing called the electron dot diagram. Dun, dun, dun. The electron dot diagram uses an element's chemical symbol and dots around it to show / represent the valence electrons. You don't remember what valence electrons are? Those valence electrons are the outer shell electrons. They're the ones on their outermost shell, farthest out. So within this, for example, we're going to take the element X. I know what you're saying. There's an element X. No, not really. It's kind of just like a space holder. This is our variable. You can put any chemical symbol in place of it. There's a pattern, a very distinct pattern you must follow whenever you are laying out and doing electron dot diagrams. The reason behind this is Hund's rule. You know how Mr. Hall told you in his class, everything that comes together. That once you learn it, you must always remember it. Because all is fair game. Think about when you look at 2s and 2p. How would we feel electrons within this? We would go, the first electron would go here and the second one would go here. That's why this matters. You're going to follow the same pattern. It's kind of like the s orbitals here. So here's your first electron. There would go your second electron. That is not the number 12. That is the first electron and the second electron. Okay? Where does the third one go? Right there in the -1 orientation. So we have 3. This is where the break is, and this is where the trick is. Where does the fourth electron go? In the 0 orientation. So it will not go right here with 3. It'll go down here. Then you have the 5th electron. Boom. So it'll come up here by itself. And then we go through and repeat. So the 6th electron is with the 3rd electron. The 7th electron is with the 4th electron. And the 8th electron is with the 5th electron. Six, 7, 8. That's the pattern of how these are filled. So 1, 2, 3, 4, 5, 6, 7, 8. And it matters. I'm going to give you a question whenever you have your next quiz, and you have to follow this pattern. So here's the key. Oh, that just reminded me. Huh. Friday is a great day. You will have your element quiz on Friday. You thought I forgot. Oh, please. It's not on my big calendar. I will not forget again. I apologize for forgetting.
We forgive you, it's okay.
I can move it up if you like. I can. No? Sure. Okay. All right. So, let's work a couple examples of these, yeah?
This is where you lose them.
No. I know lose you. This is where I gain you. And you get the understanding. And you walk out of here going, I crushed chemistry today.
I'm going to cry that I failed chemistry.
We didn't even do anything.
I still failed.
Y'all got to stop talking like this. Y'all have got me this horrible reputation that all the sophomores, whenever I bring up chemistry, they're like, I'll fail. I'm like, you know how many kids have failed chemistry? I can count it on one hand. Everyone's like, but I'll fail. And I'm like, you're the smartest kid in your class. How are you going to fail? Anyway, so for example, let's choose an element like phosphorus. Phosphorus, as you know, because you're studying for that quiz you got on Friday, your elements. Yeah. Very nice. Don't shake your head no to me. Say in this, you're going to use dots to represent the electrons. So the key to this is figuring out how many valence electrons does phosphorus have. And this is where Mr. Hall pauses and there's awkward silence in the room until somebody answers and tells me how many valence electrons phosphorus has.
It's pink.
Note that's how many total electrons.
That was not the shot. 3.
No.
4.
Stop guessing.
9.
No. Thank you. Way to go, Chastity. We have 5. How did we get 5? Phosphorus is in the 15th column. The 15th column has how many valence electrons?
How do we know that?
Because the first column has 1 valence electron, second column has 2 valence electrons. We do not worry about the D block. We go to the P block, so we jump to the 13th column. 13th column has 3 valence electrons. 14th column has 4 valence electrons. 15th column has 5 valence electrons. 16th column has 6 valence electrons. 17th column has 7 valence electrons. And the 18th column has 8 valence electrons. That is how we know that. Very good question. Let's go, Chastity. So 5 valence electrons. We have 5 electrons to represent. Within this, follow your pattern. The first electron goes right here. The second electron goes right here. Your third electron, right there. Remember the break. Don't fall in the pattern and go 1, 2, 3, 4, 5. It goes 1, 2, 3, 4, 5. And this matters. Because if you put 1, 2, 3, 4, 5, there's not an electron there, Mr. Hall knows you did not follow the pattern and you are wrong.
That's not too bad. Is that it?
Yeah, that's it. Yeah, there's not, there ain't nothing I can really add to that. That's about it.
This has to be a trick.
No, the trick is the pattern.
I mean, there's got to be something later on that's going to come back to this and kill us on it.
No, not on electron dot diagrams. No, it's pretty much simple.
So this is the calm before the storm.
I don't think so. I feel like there's more to Lewis structures, but it's like it just takes like a little bit of time and you catch on. Follow the pattern, you'll be fine. Let's do another one. You know, I feel like there's hope in this room today. It's wonderful. You know, let's do calcium. Calcium's good for your bones. You ought to give calcium a shot. I'll give you a couple seconds. I don't think it'll take much longer than that. How you doing? Very nice. I'm in a great mood. I'm ain't even halfway through my coffee. It's wonderful. How many valence electrons?
2.
It's 2. How did we get 2 valence electrons? It's in the second column. I am so proud of y'all today. I could cry tears of joy. Y'all have just warmed my heart.
Both points.
Get out.
That's very good news.
Till now. Alright, so where's the first one go?
Number 1.
In the number 1 position. Where does the second one go?
Right sided.
Right beside. Bada boom, bada bing.
Isn't that from Liberty Mutual?
Acid?
No.
Bada boom, bada bing?
Yeah.
I don't know. Isn't that the one with like the emu or whatever?
Yeah.
Like Doug and Emu, yeah. They don't say that, do they?
No, I'm thinking of Bada Boom, Bada Boom.
Oh. Alright. Anyway. Let's do selenium. Which you all know is SE because y'all are studying so hard for your element quiz on Friday. Atomic number 34 if you're still stuck there. You know, we have finally reached a great place in chemistry, and we're laying the foundation for stuff we're going to be dealing with. We're getting ready to take the element quiz. We're getting ready to bust into nomenclature, and it's just great. Then we'll get into chemical reactions, the stoichiometry. You know, we're not doing too bad. Thomas, I take it back. This kind of is the calm before the storm. By the time we get into nomenclature, it's like smacking you across the face with a 2x4.
I knew it.
Anyway, on a good news, how many valence electrons does selenium have?
6.
It has the 6 electrons. So with this, yours should look like mine. See? 1, 2, 3, 4, 4.5. Thank you. Correct me. Where does the fourth one go?
At the bottom.
At the bottom left. Thank you. 4,
They go up.
5,
And on the other side of the E.
6.
Incorrect.
9.
6.
9.
6.
9. Yes. Put it there. Just put it somewhere.
6.
Oh.
No. 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 The lid. 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 Sorry, that's what I thought it was. Just because I feel like you guys are doing so well with this.
Bonus points.
No! No bonus points. You guys are doing fantastic.
Kevin give us bonus points. It's a worksheet, Greg.
Lydia, I will give you one whenever you do it. I still gotta put in the stuff I gave you on Friday. Hey, by the way, you're supposed to turn that in to me.
We weren't in here.
We weren't in here.
What do you mean you weren't in
We went
here?
to
We
the
went
gym.
to links.
Why'd you go to the gym?
Oh yeah, that's right.
We're having a problem.
Where's that at?
The
We ran
armory.
around the armory.
What? Which one?
Probably.
We can do multiple dance floors.
Yo,
Yo, you on the bottom dance floor? Let me see you boogie on the top dance floor. It'd be great. It'd be great. All right. Anyway, yeah, I see him making that there. Okay. All right. Fine.
Automatic thunder.
Some of y'all in here need it.
Yeah, me. Really?
Do it in here. You done yet?
Yeah. Oh no, I didn't know it's up there.
Lithium, atomic number 3. How many valence electrons?
1.
Is the longest number. 1. Where does it go?
Top left corner.
Bada boom. Bada boom. Just figured it out. How do you feel?
Like we need bonus points.
Y'all are ruining my good mood. You're like ruin it for the rest of the classes today. It's
But
like
never been this involved.
I'd do a whole worksheet on
y'all gonna walk out of here crying tears and go, oh my, oh Dad, I understand chemistry. Like you too, this is great news. Questions?
No.
Okay, new thing.
What?
Got it.
Plenty of questions now.
How will this affect our studies?
In a positive way, because this was easy.
Okay, you better throw a bunch of these on the test grid. For real.
I'll throw you like 1 or 2.
Can we just have a whole test?
I'll look and I'll go, oh, Mr. Hall, that last problem's pretty hard. You need to give you a question. I give him some electron dot diagrams. That's fair. Okay, electron dot diagrams go bye-bye. And now, to the piece of resistance. What will end up becoming, quite possibly, your favorite thing.
Healthcare?
You got jokes. Hey, Lewis? And I'm not talking Lewis Automotive, okay? Lewis Structures. Lewis structures. We care in chemistry of how things are bonded together. We care about their geometric shapes they form. We care about how they look. So Lewis structures is kind of a 2D look at how stuff looks. Or let's say compounds and molecules. Now there are some rules. These rules I give you, you must follow. You must obey them. Because they are rule breakers. And they're on special circumstances. So our rules, breakers. They 40 on that.
Yeah.
And there's a very special rule that they break. You've learned it. You know it. You live it, you breathe it, you eat it. It's become every part of your being. You wake up in the morning reciting it to yourself, saying, I can't wait to get to first period.
So we can tell.
To study more on the octet rule.
The what?
The octet rule. The rule breakers of the octet rule. Da, da, da. Done. You keep that as a souvenir. You're welcome. I know some of these words. Oh no, wow, I'm just in a great mood today. The first one you must become familiar with and know is hydrogen. I know you're asking yourself, why is hydrogen a rule breaker when it comes to the octet rule? I asked myself that too. And the reason it will fill the 1s subshell. Hence, have 2 electrons. Hence, welcome back. Y'all have not missed nothing.
We're about to leave it. Yeah, we're.
Oh, okay, bye-bye. You've missed nothing. I'm
I'll
just
make
kidding.
sure I watch your handy dandy video though. Yep.
Hey, you should, because you'll feel like there's hope, and you got this, and you believe in yourself. Hey, I'm not joking. I'm serious. Ask them.
I don't know, but you scared the life out of us down there, or down here screaming like you're getting murdered.
Where do y'all even at? I ain't
It's
scared.
your rooms.
Oh, whatever. Where was I? Oh, yeah, hence. Hence. Only, and I mean only, a single bond. That word just seems fitting today. Single, because we celebrate Valentine's Day today, so for some people it's Valentine's Day, for some people Single Awareness Day. If it is Single Awareness Day for you, do not feel bad. It is all good. One day it will change. I mean, look at me. I got married. If I can get married, you got hope.
Did you know that for some people it's President's Day?
That was a good one, guys. And don't say anything else the rest of the day. You had your one, guys. Just let it go. Okay, now he's dead. I get it. I got the joke. Okay? We're here, but the banks are closed. I got you.
Wait, really?
Is it really President's Day?
Yeah, it's really President's Day.
Why are we in school?
Because you come to learn chemistry. The president would want you to do this, yes?
He wouldn't remember.
You don't know.
Didn't he graduate at the bottom of his class? College.
I have no idea. I did not research that. Number 2. This is where things get freaky. And you're like, wow. The number 2 rule breaker is boron. I know what you're thinking. Why boron? Because it has 3 valence electrons. Hence, only 3 electrons to share.
Yeah, but I thought they all had 3 in that.
Yes, but in this case, boron is that little special booger that just looks and goes, I only have 3, that's it. You can't have these 2. These 2 are hidden away. Here are these only 3 you got that we can deal with. I know. Me too. But this is why we call it the rules breaker. See? Make perfect sense? If not, that's okay. Okay, let's go up here because I got new things to add. All right. I have 2 more rule breakers for you. But they are under very special conditions. What is this? These people drive me nuts. Very special conditions, and here are your special conditions. Must be bonded with highly electronegative elements. Like, oh, I don't know, like oxygen and chlorine and fluorine. In this case, for these elements to break these rules, they must find themselves in this scenario, that they are bonded with oxygen, chlorine, and fluorine, which gives us our 3rd rule breaker. Our 3rd rule breaker, phosphorus. P for phosphorus. Phosphorus will form five bonds. Hence, have 10 valence electrons. So phosphorus can have up to 10 valence electrons. They will form 5 bonds. Your 4th and final rule breaker is sulfur. S for sulfur. S for sulfur will form 6 bonds. Hence, have 12 valence electrons. Bless you. All right.
That's enough.
See, yeah.
Yeah.
Okay, we will stop here. We will pick up on this tomorrow, and we will start working in the examples with Lewis structures. See?
Now, what does this have to do with bonding?
These are going to show the bonds. So, like, what you're actually going to do in this is, okay, like water. I know that from my head, just because I've done it 1,000 times. You will design this. You will do carbon dioxide. You will design all these beautiful little things. It's very nice. Very good question, Thomas. For the rest of you,